Let's continue our math adventure. Today, it's fractions with unlike denominators. It complicates things a little bit, but we can handle it. So let's take a look at the concepts of adding fractions. Remember, our denominators are what tells us the size of the pieces we're looking at. So if I have a denominator of 3, it means I take a whole item, such as a chocolate bar, and I'm going to cut it into 3 equal sized pieces. If I have a denominator of 2, I take the same size chocolate bar, but I'm only going to cut it into 2 equal sized pieces. Well, when I take a look at this, I cannot add these 2 fractions because my pieces are not the same size. And in math, we can only add fractions when our pieces are the same size. So what I have to do, I have to recut that candy bar to make sure that I have equal sized pieces I can add. So if I took these 3 pieces, I could cut those 3 pieces into 6 pieces. And if I took these 2 pieces, I could also cut those into 6 pieces. Now I have equal sized pieces, and that's the key for me. So when I cut those, the 2 pieces here become 4 pieces there. Same amount, just seems like there's more pieces. And this 1 piece here becomes 3 pieces there. So in the end, we're going to take a look and see how many total pieces there are. Well, we don't want to draw pictures all the time in order to do this. And so what we want to do is we want to be able to do it mathematically. And that is why we learned a concept called least common multiple. Because those least common multiples are what allow me to get denominators that are the same size. Often we call that the least common denominator, but it's the same concept. So if we take 3 and we find its multiples, I can do 3 times 1 is 3, 3 times 2 is 6. And if I take 2 and I look at its multiples, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Well, as soon as I get the common multiple of 6, that can become my least common denominator. So that means I need to multiply those denominators in order to get up to that least common denominator. So I think to myself, 3 times 2 is 6, but whatever I do on the bottom, I have to do on the top. 2 times 2 is 4. And I think 2 times 3 is 6, but whatever I do on the bottom, I have to do on the top. 1 times 3 is 3. And when I go to add those together, now I've got my common denominators. So I have a denominator of 6, and I can add those numerators. 4 plus 3 is 7. Now I know that's an improper fraction because the 7 is larger than the 6. And so that's just a division problem, and it's really 7 divided by 6. Well, 6 goes into 7 one time. I'm with 1 left over. That becomes my new numerator over my original denominator. So that's the basic concept of how we're going to add these fractions with unlike denominators. Now we're going to get away from pictures a little bit because we know we're just going to find the least common multiple to get those common denominators. So if we were just given the fraction themselves, I'm making it a little bit harder because I'm going to add a negative in there. But I can look at those denominators, I see they are not the same. So my first job is I got to find the least common denominator, also called the least common multiple, to get the same denominator. Well, I always look at the biggest number and I think to myself, does the smaller one go into the bigger one? And in this case, it does. So I know that I can have a common denominator of 8. Now I always work mine from top to bottom so that I can build my equivalent fractions coming across. So I know that I have to make an equivalent fraction of 8, but it's a negative, and I think to myself 4 times 2 equals 8 and 1 times 2 is 2. So negative 2/8 plus 1/8. Now the colors are different. These are negatives, these are positives, so we have to remember that. But all I have to do is bring down my denominator of 8, and then I think to myself, all right, I've got 1 positive there, and I've got two negatives there. And I know that the positive and negative will cancel each other out. So I'm just going to cancel that out. And I can see I have one of those negatives left. So I'm going to bring that one negative down, but I've got to keep that negative right there. So negative 1/4 plus positive 1/8 would be equal to a negative 1/8. So those integers, they complicate things, but if you take it step by step, it should be pretty easy to do. Now we can also have mixed numbers here. And remember, I like to rewrite my mixed numbers, keeping my whole numbers with my whole numbers, my fractions with my fractions. So when I looked at this, the key on this is you have to remember when you split those numbers that that negative goes with both parts. Lots of people will forget to put the negative on the fraction part, and that's going to throw your answer off. So I have negative 4 3/5 plus a positive 7 4/15. And I always start on my fraction side. So first I look at those denominators, they're not the same. So I can see that 5 can go into 15. So I'm going to rewrite this, making an equivalent fraction with 15 as the denominator. Now remember, that's negative, so I'm going to keep that negative there. Now 5 times 3 is 15, and 3 times 3 is 9. So now I have this same denominator. I can go ahead and I can add them. But remember, these are negatives and these are positives. They're going to cancel each other out. So on my fraction side, I bring down that 15, and I have negative 9 and positive 4. Therefore, I'm going to have a negative 5/15. Now, I can reduce this by dividing by 5 to get negative 1/3. But I'm not done, because I didn't even start to work with my whole numbers. Now, when I go to look at my whole numbers, I see I have 4 negatives and 7 positives. So that 7 and 4 are going to cancel each other out. I'm going to be left with more positives, so I'm going to have a positive 3. But now it's time to pull these fractions back together again. And I have a problem, because my whole number is positive, my fraction is negative. So when I go to pull them together, I actually have to cancel them out. So I'm really taking this 3 and I'm subtracting 1/3 from it. So I'm going to go down into the 2's. So when I take 3 minus 1/3, or you could write that as 3 plus a negative 1/3, they cancel each other out. I'm left with 2. One of those 1/3 is taken away, and 2/3, but my whole answer is still positive. That's a messy problem. It just shows you have to really pay attention to those positives and those negatives. Now, we also know we can have variables. So when I take a look at variables, don't let the letter throw you. All we have to do is follow the same steps that we did before. So I look at those denominators and I see they're not the same, and I have to make them the same. So I'm going to take and rewrite this. Ooh, I see minus. And remember, whenever I see subtraction, I change it to plus the opposite. So I'm going to rewrite it over here, just so I can see it better. Now, changed it to an addition problem. I'm going to keep this as negative r over 8. I look at these denominators and I think, oh, I can make them into 88. Because I can multiply this by 11 and I can multiply that by 8. So when I multiply by 11, whatever I do on the bottom, I have to do on the top. So I actually get negative 11r on top. I'm just bringing that variable over. Sometimes if you just want to place the variable, you can. And then if I multiply by 8 here, that becomes negative 72. Now they're all negative. So I've got my common denominator. I'm just going to bring it down. They're both negative, so nothing's going to cancel out. I'm just going to place my negative. I have my r and my r. I'm just going to put my r. Now my last step, just add those numerators. So if I take 72 and I add 11, 2 plus 1 is 3, 7 plus 1 is 8. 83, let me say it, negative 83r divided by 88 would be my final answer. Looks complicated, but if you take it step by step, it should work. My challenge to you, do the best you can. Make sure you get these common denominators, and I think you'll do fine.